Hi everyone! So this video is to help you be able to complete your summer homework for pre-calculus. So what I did was I came up with questions similar to the ones that are on your homework worksheet, but they're not exactly the same. So along the side, it tells you what questions they're like, so you'll be able to compare. Most of this stuff is from Algebra 1 and Algebra 2, so you should be pretty familiar with it. Some of the, like the fraction part, is even before that. So if you are working on these and you need more explanation on these problems or on your summer homework questions and you actually have questions about those, you can email me anytime at misswernermathhelp@hotmail.com and I will get back to you within a day or two. So email me any questions you have. It doesn't matter what they are. It helps me if you're working on a problem that you take a picture of your work and send that with your email so I can see what you're doing wrong, because that makes it so much easier. And then you don't really have to type as much and explain as much. Okay, so let's dive right in. So our first problem is to solve a bunch of different types of equations in that first section. So the first one is just like a regular multi-step equation. So our first goal would be to get rid of the parentheses. So we distribute. Make sure you're careful with your negatives. Combine like terms that are on the same side. And then we'll combine like terms on opposite sides. So get rid of the 3x. Combine our x's. I'm going to do this at the same time, and I'm going to add my 14 to the other side. So those cancel. It's 15 equals 5x. Cancel. So then the last step would be just to divide by our 5. So we get that x is 3. So that's just solving a multi-step equation. So our next section is solving proportions. So with proportions, we have to cross multiply to get rid of the fractions. So remember to put parentheses around them. I like to call it to give it a hug. So we give it a hug so those terms stay together, and then we cross multiply. So when we cross multiply, remember that means multiplication. So we're going to have 7 times x plus 2 equals 4 times x minus 3. And then after that, we do the steps just like what we did on the first set. So distribute, combine like terms. So we end up with 3x equals negative 26. If we divide by 3, we get x equals negative 26 over 3. And since we can't divide that, we'll leave in fractions. Like everything is fractions. Okay, so next kind is solving an absolute value equation. You should have done this, I think, last year, if not in Algebra 1. So the first step would be to get the absolute value bars by themselves, so we need to get rid of this 2. So we'll just divide both sides by 2. So you'd have the absolute value of negative 3 plus 2x equals 9. Be careful with this because you can't have an absolute value equal a negative because the absolute value is always going to be positive. So if this would have been negative 9, there'd be no solution to this problem. But sometimes once you divide, it ends up turning it into a positive. So don't think it has no solution until you get the absolute value by itself. Okay? So from here, we end up making 2 equations because absolute value can start out having a positive or negative inside of it. Like the absolute value of 2 equals 2, but the absolute value of negative 2 also equals 2. So we need to take into account both situations. So to do that, we split up our problem and we make 2 new equations. So negative 3 plus 2x equals 9. And then we're going to do the opposite of that because we can have the negative. So negative 3 plus 2x equals negative 9. So that's the key part here when you're solving absolute value equations, that you make 2 equations and one of them you change the side to the opposite side sign. And then you just solve it like regular. So if we add 3, we have 2x equals 12. So x is 6 is one solution. Add 3. So 2x equals negative 6. So x equals negative 3 is another solution. So for absolute value equations, you should end up with 2 solutions like what we just did. Okay. Our next kind is inequality, and I know on your paper there's several different kind of types of this. I'm just doing the and one. The or problems are a lot easier because it's just you have two different inequalities separated by an or. The and one is when it has two inequality signs in the same problem. So I kind of think of it like here's one set and here's another, but I do the steps to it all the same. So if I was just solving this, my first step would be to add 1. And if I was solving this, I would add 1. So I'm just going to add 1 to all of the parts. Okay, so this would give us 5 is less than 2x, which is less than 13. And then to solve that, you divide by 2. So divide all the parts by 2. So we have 5 halves is less than x, which is less than 13 halves. And that would be it for that. Okay, so our next set is basically just doing order of operations for 13 and 14. These have no variables like 15 and 16 do, so you're not like you're not combining like terms like you would here. You're just doing order of operations. So remember PEMDAS. Okay, so we'd have 2 times 3 minus 8, 2 to the third is 8, plus 27 times negative 1, plus 7 times 4. So this would be 2 times negative 5 minus 27 plus 28. So negative 10 minus 27 plus 28. I'm going to do these first because that makes it easier. So negative 10 plus 1 is negative 9. I hope we were okay with that. I know I didn't really explain. So we do exponents first, and then we do parentheses. I did exponents first because there's exponents inside parentheses. Then I did the multiplication and addition and subtraction. Okay, so for 15 and 16, it's a little bit more complicated. There's a lot of stuff going on. So inside here, I need to distribute first. Okay, so we would have 14x plus 8z minus 3y plus, and if you take a look here, we're actually distributing a 4 and I'm distributing a negative 2. So if we combine those, I'm really distributing a negative 8. So that's what I'm going to do. So then we would have negative 8 times 7 would be negative 56y minus 16z. So now here, I don't really need those brackets anymore because there's nothing left to do inside and I'm not distributing anything, so I'm just going to get rid of those. So now it would just be to combine like terms. So here's an x, we have no more x's, so we'd have 14x. Next we'll do y's because usually we put them in alphabetical order. So that would be negative 59y, we did those. And then if we combine our z's, we have negative 8z. That would be it. Okay. So next we're doing fractions. So usually the key with everything with fractions is make them improper first. So we would do 3 times 2 plus 1. So it's 7 thirds minus 19 fifths. And we have to get common denominators. Remember with adding and subtracting, it's always common denominators. Okay, so times it just by the opposite denominator. So the denominator of the other fraction is 5. So I'll times this by 5 and this by 3. So that's 35 over 15 minus 57 over 15, which equals negative 22 over 15. And then always check if you can reduce, which we can't, so that would be it for that one. So the only one you have to get common denominators for is adding and subtracting. So when you're multiplying or dividing, don't worry about it. And remember, you only combine the numerators, the denominator just stays the same for addition and subtraction. So for the next set, same idea, we're going to change them. So we'd have 36 over 5 times negative 29 over 9. And then just multiply straight across. So 36 times 29 is negative 1,444 over 45. So with multiplication, we just multiply the top and the bottom straight across. And then check to reduce. And we can divide this by 9. So we got negative 116 over 5. Okay, so division, same startup. So this would be negative 17 fifths divided by negative 4 thirds. Okay, with division though, you have an initial step. Remember, dividing by a fraction is like multiplying by its reciprocal. So we have to change it to multiplication and change this to the reciprocal. So one way to help you remember is that it's keep, change, flip. So the first fraction, we keep it the same. We've changed the sign and we flip the second fraction. We don't usually put negative signs on the denominator, so that's why I just left the negative in the numerator. Okay, and now it's multiplication, so we do what we did up here, and we go straight across. So this would be 57 over 20, and that can't be reduced, so that is all. Okay. Okay, moving on. So now we are simplifying radicals. So this is something we'll do a lot. So there's several different methods. One of the ones that I like to do is just look to see what's the biggest perfect square that can divide 756. So if you just divide by perfect squares, so not that, so 756 divided by, okay, so it can be divisible by 36. 36 is a perfect square. So one way to do it would be to change this to 36 times 21, because 36 times 21 is 756. And then the square root of 36 is 6, and there's no square root of 21, so it would just stay inside, and that would be it. Okay, if you don't understand what I just did or don't like that way, the other way is to make a factor tree for 756. So I always just start dividing by 2s. So 756 divided by 2, 378, divide by 2 again, 189, or 2, it's 189, and that's divisible by 3, and that's divisible by 3, and that's divisible by 3. Okay, so we found all the prime numbers. So 756 equals 2 times 2 times 3 times 3 times 3 times 7. So you're looking for pairs. So we have one pair of 2s and one pair of 3s. So to find our final answer, we would put a number from those pairs on the outside. So we have one pair of 2s, one pair of 3s, and anything that doesn't have a pair gets left inside the radical. So that's 3 times 7. And then we just multiply. So that's 6 root 21, which is the same thing we got when we did it the other way. So you can either do the perfect square method or factor tree method. It doesn't matter. Okay, so for the next set, we're multiplying radicals. So when we do this, we multiply the pieces that are the same. So we're going to multiply the outsides together and multiply the insides together. So 3 times 5 is 15. 3 times 6 is 18. And then we'd have to try to simplify a radical. So this would be 15 times 9 times 2. So 15 times 3 root 2, since this is the square root of 3. Or square root of 9 is 3. So our final answer would be 45 root 2. You can also do the factor tree thing for 18. You get 2 times 9 and 3 times 3. So we had one couple of 3s and then 1 2 left inside. So that's it for that one. So the next set, we're kind of distributing here. So we just distribute. So this would be 7 root 2 minus the square root of 4. And the square root of 4 is 2. So we'd have 7 root 2 minus 2. And that would be it for that one. Okay, so for the next set, we're rationalizing the denominator, which means we're getting rid of the square root in the bottom. So to do this, we have to use conjugates. So remember, conjugate is a binomial, but with the opposite sign. So to get rid of the radical, we multiply the top and the bottom by the conjugate of the bottom. So 1 plus the square root of 3. Okay, so in the top, we just have 2 times 1 plus the square root of 3, so we'll distribute. So that would be 2 plus 2 root 3. So remember, our goal here is to get rid of the radicals in the denominator. So watch what happens. So now if we distribute in the bottom, it's kind of like foiling. So we'd have 1 times 1, 1 times root 3, negative root 3 times 1, and negative root 3 times negative, or positive root 3, so that'd be negative root 9. Okay, so if we simplify the bottom, those cancel out because we have positive and negative, which is why we use the conjugate, because it gives us both. And then the square root of 9 is 3, so 1 minus 3. So this would equal 2 plus 2 root 3 over negative 2. And then you always check to see if you simplify, and since both of those are 2's, we can divide that out. So we'd have negative 1 minus root 3. And that is it for that. Okay, so for our next one, we're trying to write an equation. So we're going to use point-slope form. So y minus y1 equals m times x minus x1. Okay, this is our m, this is our x1 and y1. So we plug everything in. So we have y minus 7 equals negative 1/3 times x minus negative 4. This is really plus 4. Okay, so there's a couple different ways going from here. We want the y by itself because you always end up writing it in slope-intercept form. So you could distribute, you can try to get rid of the fraction and then solve for y from there. I usually just distribute, but then you're obviously going to have to be able to solve with your fractions. So let's do that distributing. So our last step would be to add 7, but we really need it in terms of like thirds. So if we want to get this to common denominators with a denominator of 3, we would times the top and bottom by 3. So if I'm adding 7, I'm really adding 21/3 to make it the same. Okay, so we end up with negative 1/3 x, and negative 4 plus 21 is 17/3. And that's it for that one. Okay, so same idea for the next step, but now we're trying to make it perpendicular to this line. So if you remember from Algebra 1 or geometry, to get it perpendicular, you have to change the slope. So the slope is the opposite reciprocal, so we're really going to use a slope of negative 2/3. So that would be y minus 1 equals negative 2/3 times x plus 6. So this one's pretty awesome because 2/3, we can take 2/3 to 6. So we have y minus 1 equals negative 2/3 x. So 2/3 times 6, you can work out that fraction, it's just 4. Add 1. So we get y equals negative 2/3 x minus 3. And that would be it. Okay, so next we're working on graphing, I think. What is this? Yes, we're graphing these. So for linear ones, it's just y equals mx plus b. So this is m, this is b. So if we were to graph, we go up 1 and put a point. And then remember slope, we have rise over run. So I'm going to go down 2 since it was negative, and then go over 3. And then you can do that again. You could do the opposite to get to the points on the other side, but that's really it. Okay, so for this one, if you remember how to graph parabolas, I would do it that way, but I said in the directions to make table for nonlinear functions in case you didn't remember how to graph it. So that's, you just pick some points and plug them in. For things like this, I would put the vertex in the middle if you remember how to find the vertex. So the x-coordinate was negative b over 2a. So negative 2 over 2 times 1. So that'll give us 1. So that means that the vertex is at 1. So I would put that in the center of your table. And then just do some numbers on either side. So if you plug in points into here, you should get out your y-coordinates. So this would be, if you plug in 0, I'm not going to do it for you. 0, that'll be 1. 9 minus 6 is 3 plus 1 is 4. So just plug them in if you don't understand where I got those. And then after that, you would just graph those points to get your parabola. So there's the middle 3. It would look something like that. Okay, so for the rest of those functions, if you're not sure, like the special tricks to graph them, like I said, just plug in points and make a table and you'll be fine. Okay, so 56 is distributing, basically. When it's a binomial or trinomial, what I do is I'll distribute the first term, so we would have 2x to the third times 6x squared minus 12x. I'll distribute the last one. But I end up, instead of writing them all out and trying to find like terms, I put them underneath each other. So negative 1 times x is negative x squared. This would be negative 3x, and then that would be positive 6. Now I can just add my like terms straight down and not have to try to hunt them out from the list of stuff. You don't have to do it that way, but I think it helps, makes it easy. Okay, so for 60 through 71, it's all factoring. So each problem is different. Always check for a greatest common factor first, and then look from there what you can do. So this one has a GCF, so I'm going to factor out that GCF first. So remember, that means it's something that every term can be divided by. Okay, so this one could all be divided by 3, so I took that out. So now we're trying to factor the rest of the parenthesis. So when you're factoring, remember, it's what times to be this last term, and it adds to be the middle term. So the factors of negative 15 are 1, 15, 3, and 5. Since it's negative, it has to add to be a positive. That means that these are going to be the negative ones. So the ones that make 2 would be negative 3 and positive 5. So for that problem, that's it. Okay, and there's several of them like that one. For this one, this is called a difference of perfect squares. So there's like a pattern to it. It always has a parenthesis that's minus, and it always has one that's plus. Okay, and then to find the terms, the first term is just the square root of the first term there. So we'd have 11x and 11x, which makes sense because if you times them together, you get 121x squared. And then the square root of 25 is just 5. So that's it for that one. Okay, so this one is a little bit more complicated. That's why I saved it to the end. I use the trident method. I'm not sure if you guys have heard of that before. It's kind of similar to what this is, except there's no GCF, so we're not going to divide anything out to start. So what we end up doing is we make 2 parentheses, and we put a 6x in both of them. I don't know why it's wrote so big. Okay, so that's the first step. So now the next step is to find our factors. But instead of just being this last one, since there was a number in the front, we have to take count of that too. So we actually times those together. So we're going to find factors of negative 12, since that's what we got when we times, that add together to be that middle term, which is 1. So the factors of negative 12 that add to be 1. So 1, 12, 2, 6, 3, 4. So since they have to add to be a positive, it's going to be the smaller ones that are going to be negative. So the numbers that add to be 1 are negative 3 and positive 4. And I know what you're thinking. Well, those can't be the factors of that quadratic, because if you do 6 times 6, you don't get 6. Okay, that's because we put an extra 6 when we did this in the beginning, and now we have to try to get it out. So I think of it as reducing a fraction. If I had a fraction with 6 and 3, what would I reduce by? Well, I could divide them both by 3. So I'd end up with 2x minus 1. And these I can divide both by 2, so I'd end up with 3x plus 2. Okay, so that is all. Okay, so factoring is a big deal, and you're going to have to know how to factor and be able to do it like without much effort. So I would definitely practice those. That's a really important skill. If you need more help with those, like I said, you can email me. Okay, so for 72 through 74, this said to solve by completing the square. So to complete the square first, we need to get the squared term and the regular x term by itself and get the number on the other side. So we would have x squared plus 6x, if I add 2, will equal 2. So now we have to find the number that makes this a perfect square trinomial. So to find the square, you use the formula b over 2 squared. Remember, it's a, b, c, so our b is 6. So that would be 6 over 2 squared. So 3 squared is 9. So our number that completes our square is 9. So we'll add 9 to both sides of our equation. Okay, so that completes the square. Now we just have to solve, since it's solved to complete the square. And my pencil just died. Okay, so that means we have to factor this. So if we factor this, we would have, it's a perfect square trinomial. So the factors are x plus 3, x plus 3. So usually we just jump right to saying this is x plus 3 squared, because it's always going to factor that way. The factors are 9 that add to be 6. It's a perfect square trinomial. Okay, so the next step to solve this would be to get rid of the squared. So to get rid of a square, we take the square root. So we'd have x plus 3 equals, remember when you're solving an equation by square roots, you always put plus or minus. And then the last step would be to subtract that 3. So x equals negative 3 plus or minus the square root of 11. And that's it. Okay, so for 75 through 77, it said the quadratic formula was our method. So remember the formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So a, b, c. So if we plug those in, we have negative 2 plus or minus the square root of 3 squared minus 4 times 3 times 1 all over 2 times 3. And then we just simplify from there. So use your order of operations. So 2 plus or minus the square root of 9 minus 12 over 6. So this would be 2 plus or minus the square root of negative 3 over 6, which is 2 plus or minus I square root of 3 over 6. And that is where we would leave it. Okay, if you can simplify radicals, you should. If you can simplify the fraction, you should. But for this one, we can't. So that would be it for that one. Okay, 78 through 80 is using the Pythagorean theorem to find the missing side of a triangle. So a squared plus b squared equals c squared. Pretty sure we're okay with this. I'm just going to do it real quick. So we plug in our numbers, square them. So we would subtract our 49. So we end up with b squared equaling 120. So if we take the square root of both sides. When you're solving for the Pythagorean theorem, you're not going to have to put the plus or minus because the numbers represent, I simplified the radical there. The numbers represent sides of a triangle, and our side of a triangle can't be negative. Okay? So to simplify the radical, you can do your factor tree like we talked about on the front. Okay? Okay, so our next set is involving exponents. If it's a division problem, when you're dividing, just divide each piece. So this would be 6. When you're dividing these, we subtract the exponent. So 6 minus 1 is 5. Negative 2 minus 4 is negative 6. And then 2 minus negative 2 is 4. So z is 4. And then remember with exponents, if they're negative, they have to move to the other side of the fraction. So anything that has a positive exponent would stay in top, and then the negative ones would go into the bottom. Okay, so if we're multiplying, like the second problem here, we add the exponents, except for the number part, we just times. So that's 8x, or 2 plus 1 is 3, and that'll be negative 1. So it would have to go in the bottom. So we'd have 8x to the third over y. So if we have fraction exponents, you can remember from algebra 2, this is like the index of the radical. So this would be equal to the 4th root of 256. So that means what times itself 4 times is 256. I'm pretty sure it's 4. The 4th is 256, yep. So this answer is just 4. Okay, and our last set is simplifying rational expressions. And then there's a couple different types in there. I picked the hardest one because the other ones you're just factoring and simplifying. Here you're factoring and dividing. So what I would do is I would just factor all the pieces. Remember, if it's division, we change it to multiplication and flip this over. Okay, so to factor this, we take out the 6. To factor the bottom, it's a 2 parenthesis 1, with times to be negative 21 and adds to be 4. Negative 4. I don't know why I read the 4. So times to be the end, add to be the middle. So that would be negative 7 and positive 3. So I'm going to flip it and put this on the bottom. Take out the GCF. So on the top, which was the old bottom, with times to be negative 6 and add to be 1. Minus 2 and plus 3. So once you factor for all of these, then the next step would be to cancel any common factor. So if it's in the top and the bottom, you can cancel it out. So we can cancel out these x minus 2s, the x plus 3s, not those. Okay. We also have a 6 and a 4 in the top, so we can reduce those by 3 as well. So we'd have 3 over 2, and then the other part, we have an x minus 1 in the top and x minus 7 in the bottom. And that would be it. So if you have any questions on any of the work that I just did or on your summer homework, remember you can email me at Ms. Warner Math Help. Take a picture of your work and send that to me, and that would help. So I hope you've had a great summer, and I will see you next school year.